Hello, this is Ms. DB. In this video, we are going to learn more about functions, including how to classify them as discrete or continuous, and describe the domain and range of relations and functions. So, whoops, where'd she go? So some of these things you've already talked about before, you've already learned about, but there's a nice graph table here that has a summary of continuous functions and discrete functions. So a continuous function, when you graph it, you can draw a straight line or a curve. It doesn't have to be a straight line. And there are no holes or gaps. You should be able to just make one motion with your pencil or pen, and there you can see there's no gaps. This is a linear function. Lines are always functions unless they are vertical lines. Vertical lines are not functions. Here's an example of a discrete graph over here. It's just a set of points. You do not connect the points. You do not draw a curve or a line through them. The points might go in a line or might make a pattern, but you don't connect them for discrete. It's just points. So a description for continuous function is that it allows the x values to be any points in the interval. So there are points along this line. Like you might have made this graph by putting points on a graph and then drawing a line through it, but that doesn't make it be a discrete function just because you used points to create it. Because there are also points in between that would also be on this graph. They might be fractions or decimals, but there's still points that would lie on this line. So there are infinite number of points that lie on that line. In a discrete function, there are no points in between the points that are listed. There's nothing there. There's no data there. There's no data here. We do not include the fractional or decimal values that are in between the points that are on the graph. Some real-world examples of a continuous function would be growth. As a plant grows, that grows continuously. You can measure incremental parts of an inch as it continues to grow. Time is continuous. There's fractional parts even of seconds. Temperature, volume, algebraic functions like linear functions, quadratic functions, sets like the real numbers. So all real numbers is a continuous function. Examples of discrete is when you're counting things, like how many children do you have, how many pets do you have, how many plates in your house. If you're counting an item, those are discrete objects. You can't have fractional parts of a pet. You just have 1, 2, 3, 4. And if you're looking at sets of numbers, the whole numbers, the integers, and the natural numbers are all examples of discrete functions because those do not include the fractional parts in between them. The domain of a continuous function, you're going to write it, sometimes it's all real numbers, but often we'll write it with an inequality, like maybe x is greater than 0, or x is between -5 and 5. Those are examples of domains of continuous functions. But when you write a domain of a discrete function, you just list the points of the x coordinates. So in this example up here, the domain would be 1, 4, 5, and 7. You can just read them off of the table. The range of a continuous function is also going to be described as an inequality, but you'll be describing the y values, or again, it might be something like all real numbers. The range of a discrete function is also going to be a list of points. For example, in this graph, the range would be the y values, which are 3, 6, 8, and 9. So in a discrete function, you list the values of the points. In a continuous function, you'll use an inequality to describe the domain and range, or again, sometimes it's just all real numbers. These are some example problems of how to decide whether you have a discrete or continuous function. A bank account. In their explanation, they said that it's counted in dollars and cents, not fractions of a cent, so it would be discrete. Number of pets in a home, we talked about that one. Age of students in this class. Age is always increasing. You're always getting a little bit older. So the age is a continuous function. Even if you say a number, like how old are you? I'm 17. You would make this be a continuous function if you were to graph it. You would connect those points with a smooth curve, because there are going to be somebody who is 17 years and 3 months and 1 day and 2 minutes and 7 seconds and 13, 16, 17. You can get incrementally smaller amounts of time to represent that. You're always continuously aging, unfortunately. Now, the number of students taking this class, that's just counting. 1, 2, 3, 4, 5, 6, 7. You would just say it's 21. That's it. It's done. You write it down. Max makes $15 an hour at his job. This is usually continuous function, because he might work, 1 hour and 7 minutes. It kind of depends on the time card and how you write it down. Some places have you round to the nearest hour or nearest 15 minutes, but usually this is now done on a computer and you're getting paid for every minute you're there. So it kind of depends. In this example, we decided it was continuous because he might work any length of time. For numbers 1 through, is it 10? 1 through 10, you're going to write continuous or discrete for each of these situations. There's 2 of them that are a graph, so you can look back at the examples there. Let's look at number 11. This is also, you say if it's continuous or discrete. It says it can be used to convert meters into feet. Measurements like feet and meters will be continuous because you can measure in parts of a foot or parts of a meter. Number 12, you're going to write a function rule, a formula that will tell you how tall your plant is at any time in the future, and then decide if this is continuous or discrete. It says that you have a corn plant that'll grow 1.25 inches each month, and it's starting at 6 feet tall right now, so it's quite tall already. So that'll be your starting point, and then you'll add the 1.25 per month to write your function rule. Let's look at number 14. 14 says a local neighborhood homeowners association is asking the community residents to participate in a recycling initiative. At the end of each week, each resident is asked to submit the number of plastic containers they recycled to the homeowners association. That's what HOA is. The data collected was compiled in the following table. So we've got one house did 28 containers, house number 2 did 49, and so on. Does this table represent data that is continuous or discrete? So you decide on that. And then what would a graph of this data look like? So after you decide for A, if it's discrete or continuous, you can describe your graph. It doesn't say that you need to make the graph. You just need to describe what it would look like. If it was a continuous function, you would say that it was a line connecting the points and it's a smooth curve, or maybe it's a U shape or an upside down U shape. If it's a discrete and you just have a set of points, then you would say it's just a set of points. And then it says, could you use the graph to make a prediction? So you might want to look at what your values are and decide if it's showing a trend, or if it's random, then you can't use it to make a prediction. All right, a little bit more about domain and range of a function. The domain is all the values that go into a function. It's also known as the input and the x values. That's the domain, what's going into a function. The range is the set of output. It's also the y values, and it's the values that are coming out of a function. Here's an example of a function, f of x equals x squared, or y equals x squared, same thing. So you take your numbers of your domain and plug them in, and what comes out is the range. So you substitute these in, get your answer, that's the range. In these next two examples, you're going to find the domain and range of a graph. So in the first one, this is a discrete function. The domain and range will just be a list of points. So I just listed the x-coordinates. So here's the lowest x-coordinate, then the next lowest, then the next one, then the next one, then the next one. And you would just write them in order from least to greatest. If there's any numbers that show up more than once, you just write them down one time. You don't repeat them. Look at the range. The range had two y values that repeated, 4, but I only wrote one down. You don't need more than one written down. And in this one, this is a continuous function. There's no limit to what the x values can or can't be. It can be anything. So for the domain, you would write all real numbers. However, the y values, you can see they're only going to be positive. They're always 0 or greater than 0 on both sides of this. So for the range, you would write y is greater than or equal to 0. That's for a continuous function. For the remaining problems, you're going to be looking at graphs and deciding what the domain or the range is, depending on the question. And it's a matching thing so that you can pick the right inequality or description of the domain for each graph. So remember to read carefully if you're looking for the domain, which is x values, so the x values are on the horizontal axis, or the range, like in number 15, you're looking for the range, which is the y values. In number 16, you'll find the domain and the range of this quadratic function. And same with 17, find both the domain and range of this function. Here's a discrete function, so the domain and range of that, and that's the last one. All right, let me know if you have any questions.